let's have a look now at the advanced functions. The advanced functions, as I said, are totally independent of the channel. So you can use them with any other KNX device. This makes the PowerBlock a very interesting product to have in your installation, because often you need some additional functions in the other devices which they don't have, and you can make use of this type of device like the PowerBlock. So this some other devices in KNX don't have this much functionality, and sometimes you need this. So if you have PowerBlock actuators in your installation, you can use, for instance, a scene or a set point or advanced scene. I will explain now the different functions which are there. They have input objects and output objects. So you can link group addresses to the inputs, and then the output can send a telegram to the bus controlling any other actuator or any other device in the installation. Now, the alarms I already explained, which can be linked then to the inputs, to the actuator, to the outputs of the actuator. It also has status of the alarm. So these status of the alarms can also be used independent of the outputs. Then the set points are very interesting. It's like a 2-point regulator, like a threshold which can be used for as additionally to the alarms. We have the output, the channel will be blocked. Okay, in the set points you can decide what should happen. You can send a set point, the output of the set point, to an alarm, to a disable function of the output, or just to trigger an event in the device. So it's a 2-point regulator, with the difference, it's not only for temperature. You can use it for anything. So it can even be used for energy values. So you can set a set point to have a threshold for energy value, and then you can switch the channel on or off depending on the energy values which are coming. So it can be used even to control loads depending on the energy. Or you can use it for wind speed, or for the brightness of the outside brightness, for instance, that the shutter goes up or down depending on the brightness. The difference, as I said, to the alarm, it will block the output, and the set point just moves the output to the new position. Okay, so these are very, very interesting functions which can be used. You can even use it as a thermostat, as a room thermostat, so that but with a 2-point regulation, so that you can control a valve to switch on and off the radiator, for instance, of the heating element of a room. But as I said, it's a 2-point regulator. Then the scenes, there are 2 types of scenes: the normal scenes and the advanced scenes. These are scene modules with its input object and output objects, which can then be linked to different actuators which don't have a scene function, or to different devices which don't have the scene object. So these output objects can be set to any data point type, or any one of the normal data point types, so that you can send, for instance, this one on, this one off, this one to 80%, and so on. Okay, the actuator has 2 scene modules. These scene modules are totally independent modules with its own input objects and its own output objects. The output objects can be configured, and the input object is in the KNX scene module, the standard KNX input object. And in the advanced scene module, it's a different, you can decide the data point type of this object, and you can decide the value it should receive to play, record, stop, or restore this function. So it's a much more flexible scene than the normal KNX scene, because the normal KNX scene, as you know, 0 is for scene 1, 128 is to save scene 1, and you cannot change that. That's always fixed. Whereas in the advanced scene module, you have the possibility to decide with 22 degrees you launch the scene, or the value 1 is to play, and the value 10 is to record, and the value 11 is to stop, or whatever. So you can decide exactly the different values for the different functions it should do. So the normal scene event, you can set the output objects for as a 1 byte or 1 bit or different types of data points. And you can say, for instance, switch on or switch off or go to 80% and so on. In the advanced scene functions object, you can do the same as in the normal scenes, but you can even set delays in between. So you can say switch on, wait 10 seconds, then go to 80%, then wait some time, go to 30%, and you can do then delays in between the events, which makes it also much more flexible, much nicer to use. And another thing, let's have a look at the trigger of the advanced scene. You can play is just to do the actions of that scene. Record, you can decide how you want to record. You can set it with a read request to the bus, or just record the last values of this object into the memory of the device for that scene. So if you, this is very, very useful. So the end customer can go and he switches this light on, he dims this one to 80%, he lowers the blind to 60%, and he sets his scene as he wants it, goes to the button, and presses, for instance, a long press to record the scene. And then he presses short, and it will automatically reproduce the scene as it was there. If there were delays in between events, usually those delays between events is for the same data point type. So if the data point type, the same group address is used various times in this with different delay times in between, and you record, it will not overwrite this sequence, because this is a sequence. This is not some single event you want to record. So if you set it to record a single event, it will overwrite that. But if there was a sequence, it will not overwrite this with the record functions. So it will still switch on, wait 5 seconds, switch off, wait 10 seconds, switch on again. So this sequence will be maintained with the record function, which is also very interesting. Then you have the possibility to stop the scene, because now there are delay times in between, so a scene can take long. You can even set the delay to be 1 hour between event and event. So then you can stop the scene so that it doesn't go on. And then you have got a very, very interesting function, which is called the restore function. So the restore is, if you say you play a scene, and the scene switches off all the lights and maybe switches on only the lights in the, let's say it's a movie scene, and only the lights of the movie room are switched the way you want. But now the whole house, let's say the whole building, you switch off the lights. And only this small part of the house is now on. Now, maybe you made a mistake by pressing the button. You didn't want to press that, and now everybody has to go stand up and restore the way it was before. Now, with the restore function, you can press the button and restore everything as it was before. Everything with the same in the same state as it was before. So you don't need to go physically one by one and switch on the lights or switch off the lights or lower the blinds or higher the blinds as they were before. It will restore to the previous value, because the scene model saves always the last state before the scene was reproduced. Okay, so this is also a very, very interesting function, which I don't know any other KNX device apart from the iPass devices which can do that. Okay, so these are the advanced scenes. Then additionally to this, we've got 20 logic functions. Now this 20 logic functions you can set to be used as Boolean logic, gate filter logic, mathematical, or comparators. The Boolean logic can be used as normal AND, NAND, or NOR, XOR, XNOR, the typical Boolean logic. And it's also very interesting, the configuration of that. So you can decide what happens with the input. Should the input trigger event on the output or not? Should the output send always the changes or only on change? Send it cyclically or not? The enable, disable functions of the logic. So it's very interesting logic here. Gate filter is also a very nice function. You can use a 1-bit object to block what is going into the output. There's an input and an output, or let's say the input and the output, and then there's a block object, so you can block what is going in from the input to the output. Now, if it's blocked, if you send something here, it won't go to the output. If you unblock this, whatever comes in here goes out there. But you can also use it as a trigger. So this is the input, this is the output, and you can set, when I block it, it doesn't do anything. If I unblock it, it will send the input to the output. So it triggers then the input to the output, which is also nice to have. Then the mathematical functions, add, subtract, multiply, divide, maximum, minimum, average values with a lot of different functions with you can set. Then the comparators, equal, greater, smaller, greater or equal, smaller, equal, distinct. So there's also a very, very complete comparator function. I'm not going to go through the exact details of those functions. Then you've got converters, which can convert the data point type from one data point type to the other data point type, and you can decide if your output value is higher than the data point type allowed value, what should happen, or if it's lower than the data point type value, what should happen. So you can define the converters. Then very, very important are the override end user parameters functions. Now, a lot of modules, you have got the possibility to interact. The end customer can make changes. Now, in the PowerBlock, you also have this possibility, and even more, because there are so many objects which the end customer can change, much more than any other KNX device I know of. So the end customer can set the different set points. He can set the new values for the presets. He can set different behaviors in the device. He can change his scenes. He can do so many different things to set different values in the actuator. But that's a lot of work, because the end customer has to go and think how he wants this. He needs to go to the visualization. He sets the new values. He spends a lot of time and effort to leave the installation perfect as he wants, which it's a big advantage, because otherwise he has to call the integrator for each and every small change he wants to make. But now he set it up, and some other actuators are so stupid, then if you program the device again with the ETS, all his hard work which he done goes away, gets lost. Because some of the actuators don't have, or a lot of actuators don't have the override end user parameters function. Now here in the PowerBlock, you have the possibility to set it individually or totally. You can say, what should happen? If I download the application program, override all the end user parameters, don't override any of the end user parameters, or do it individually. And if you say do it individually, you can say even the number of the scene you don't want to override and the rest you should override, for instance. You can say, I want scene number 1, 2, 5 not to be overwritten, because those are the scenes the customer told me he has changed. All the others should be reset to the default values which were set in the application program. So then you can go into those functions, you can set those scenes not to be overwritten, and the rest will be overwritten. This is very important, that your device has these functions, this possibility. And it's very nice. You can do any of the end user parameters, you can set individually how you want them. Then also the behavior at bus recovery, which is also very, very important, so that you can set different behaviors for the device in general to send the status values, for instance, of the device after a delay, set different delay times and cyclic sending telegrams. Even you can have a 1-bit object which can be used to say when the bus voltage comes back, it can send a telegram to the bus. This can be used, for instance, to trigger a scene, and this scene can then do a lot of different things in the cane installation when the bus comes back. So this is also very interesting. So as you can see, the power block has a tremendous amount of functions which can be used, but it's not compulsory to use them. So it's very, very, very nice. And keep in mind, the default functions, don't be afraid to use power blocks, because they are extremely easy to configure if you don't need the functions. Very, very easy, because the default functions are the ones which are you need usually in the beginning, and they are already set the way they should be. So you just import the application program in the ETS, you link the group registers to the objects, and they will work. Okay, so these additional functions, these advanced functions which I've explained to you now, are functions which are very useful to have them prepared or have them there if you need them. But if you don't need them, they are there, just there. Okay, so thanks a lot. I hope you like the introduction. We will also have a more detailed explanation of the functions. I hope we will also do webinars of the different devices. Please keep in contact, and if you have any questions, call Futurasmus, either technical questions or the commercial staff. Thanks a lot.